Hello, my name is Sourabh Singh. I'm a PhD candidate at DCNS Delft. This is my presentation on my conference paper on end-of-life influencing factors for dielectric bridge components in flow battery application. Flow batteries are used for grid energy storage, which are relatively cheap and do not require rare earth metals. This work focuses on the reliability of the dielectric bridge converter, which is needed to control the power flow between battery and the AC-DC converter. This is the circuit schematic of a dielectric bridge. Terminal 1 on the left hand side is connected to an AC-DC converter, so it's assumed that voltage V1 is going to be constant. Terminal 2 is connected to a flow battery, so voltage V2 is going to vary as the SOC of the battery changes, as the battery charges and discharges. Now, to understand the reliability of all the components, it's important to understand how the thermal stresses in all the devices are created, and to understand that we have to see how the current in all the devices change as the voltage changes. I'm going to use an analytical model of the electric bridge to show you these changes. So this is how the currents change at the rated power of the electric bridge, which here is 10 kilowatts. So this is how all the currents change when the battery charges and discharges. Please note that the B2 diode and B1 IGBT current is much lower than these other two devices when the battery charges. On the other hand, it's much higher than the other two devices when the battery is discharging. So this is how the power losses in all the devices change as the voltage V2 varies during charge and discharge. Now, assuming that the converter is allowed to cool down, the minimum temperature is going to be ambient temperature, but the maximum temperature will be corresponding to the maximum power loss. Here it's around 340 watts and here it's around 290 watts. So this asymmetric loss will result in asymmetric thermal stress in devices. It's also possible that the operating power when charging and discharging is significantly different. So here it's 10 kilowatt of operating power and 7 kilowatts of operating power during discharge. So power losses in all the devices will be significantly different in these two cases, and they will lead to asymmetrical thermal stresses. This work has been carried out under PowerRise project. Thanks to IEEE IES and IES SYPA for their support.